So one of the hardest things in chemistry that a lot of people do struggle with is being able to convert moles to grams, grams to moles, or either of those to molecules. And initially it is hard, but when you think of it as a unit conversion, it makes life much, much easier. So right here I have sodium bicarbonate, which is just baking soda, and which is NaHCO3. So this is a molecule. It's more than one element, so it's going to help us kind of determine the three things I want to show how to do. Mole to gram, mole to number of molecules or atoms, and then grams to number of molecules or atoms, depending on the situation. So in this case, it's going to be molecules, but if it's just one thing, let's say it's just like carbon, then it will be atoms itself. There's a couple ratios that you want to know. The first one is what a mole is. A mole is just a way of counting. So 1 mole is equal to 6.02 times 10 to the 23 atoms or molecules. Like again, depending on what's going on. So if it's sodium, 1 mole is 6.02 times 10 to the 23 molecules of NaHCO3 or sodium bicarbonate. The other thing that you want to know is that 1 mole of something is equal to its AMU, atomic mass unit. So if you have so many grams of this, it will equal 1 mole. So let's kind of look at sodium bicarbonate. So sodium has a molar mass. If you look at the periodic table, it's going to have a molar mass of, or at least on an AMU, it's going to have 22.99. Hydrogen is 1.01. Carbon is 12.01. And then oxygen, I should have done a different color. Actually, let me redo this. So let me just erase this, give myself more room. So again, 1 mole is equal to the AMU in grams, which is kind of weird, but I'll explain it. So the number, atomic mass number of sodium, let me choose a different color, is 22.99. So that's sodium. Hydrogen is 1.01, carbon is 12.01, and oxygen is 16.00. It's actually 15.999, but we'll just round it off to the hundreds. So these are the atomic mass units of these atoms. If we add it all together, it will be the atomic mass of sodium bicarbonate. So let me grab my calculator. Clear. 22.99 plus 1.01 plus 12.01. And then I need 3 oxygen, so technically I need to multiply this by 3. So plus 16 plus 16 plus 16 equals 84.01. And let me just make sure I did it right. I hate making mistakes, so I want to make sure I did not make a mistake. .01. So this is the AMU, atomic mass unit of sodium bicarbonate. Now, if we just change the AMU and we just said we had 84.01 grams of NaHCO3, if you have this much, it's equal to 1 mole. That's how we got the definition of mole. We looked at the AMU, measured it in grams, and then that will be in moles. So that's the relationship here. We have 1 mole is equal to 6.02 times 10 to the 23 stuff. 1 mole is equal to the atomic mass unit in grams of that. So now we have 2 conversions or 2 ratios that we're going to use to help us solve this. So the first one is we're going from moles to gram. So let's say we had, let's see, just make up a number, 2.4 moles of sodium bicarbonate, NaHCO3. Now then I'm going to look over here and say, okay, I want to go from moles to grams, so I want to look at the relationship that has grams and moles, and that's this one, moles and grams. So when you use that ratio, I have 1 mole equal to 84.01 grams of NaCl. I have moles here, so when I'm going to do my unit cancellation, I want moles on the bottom. Then I'm going to get the coefficients, 1, and then the other matching one is 84.01 grams. Now when I have this in this ratio, the moles cancel out. And when you just multiply 2.4 times 84, I get 201.624 grams. Now, we want to make sure we stay with the sig figs. Since there's only 2 here, this should really only be 2. So to do this perfectly, it should be 2.0 times 10 to the 12 grams of NaHCO3. But that's how you do it. Sig figs without sig figs, but you kind of get the point. So it's a unit cancellation. We're looking at the relationships. This is always true, no matter what molecule it is or atom. This is true, but you need to do some work to get the atomic mass unit. So hopefully I showed you here. Now let's say we have the same amount of moles, 2.4 moles of NaHCO3, and I want to change it to molecules. Well, now let's look over here. Let me kind of erase some of this stuff so we don't get it confused. All right, so we have moles and molecules. So moles to grams is not the one we want. With moles to this one, atoms or molecules. So here, we don't even need the molar mass of the object. All we need is Avogadro's number. It is, again, a unit cancellation. So I have moles on the bottom. And here's a ratio. 1 mole is equal to 6.02 times 10 to the 23. I'm going to put a number sign, but molecules. So the moles cancel out. You multiply that. Put in your calculator. 2.4 times 6.02 second EE 23. And I get 1.4448 times 10 to the 24. Okay, and we start off with 2 sig figs again. So 1.4 times 10 to the 24 molecules of NaHCO3. So that's kind of how you do that one. And it doesn't matter which way. So let's say you wanted to go from molecules to moles. It's the same ratio, but you're just going to flip it because you're going to start with, instead of moles, you're going to start with molecules, number of molecules. So if that is the case, then instead of moles being on the bottom, it's going to be 6.02 times 10 to the 23 molecules, and you're going to have moles on top. So it's the same thing, but you're just going to flip the ratio. So what you want is on top, what you want to cancel out is on bottom. Same thing here. If you wanted to go backwards from grams to moles, you do the same thing. So if you, let's say you had 2.4 grams of something, you want to make sure the 84.01 grams on the bottom and the 1 mole is on the top. So if you're going forward or backwards, the same ratio. It's just you want what you want to cancel out at the bottom versus what you want on the top. All right. This one is technically the hardest one because there's no real jump from one to another. So technically there is, if you could work it out in your head, but I personally think it's better to kind of go through the steps, and then once you do it a bunch of times, maybe you can skip it in your head, but I'll show you at least the first way. So number 3 is actually a combination of 1 and 2 because there is no direct relationship from grams to molecules. So you have grams to moles and then moles to molecules, but you don't have grams directly to molecules. So we're going to do a 2-step thing. So let's say we do have 2.4 grams, and I'm going to keep it NaHCO2, or sorry, CO3, sodium bicarbonate, just to make my math easier because I already know its molar mass. So here I have grams, and I want to eventually get to molecules. So okay, since I have no direct path, my goal is from grams to moles, and then moles to molecules. So the first thing I want to get rid of is grams, and I want to gain moles. So if I look, okay, where do I have that relationship? That's this one. So 1 mole is equal to 84.01 grams. So now I got rid of the grams, and now I have moles. Remember, I want molecules. That's my goal. Molecules. So here I have moles on top, so I want to cancel it out. So I'm going to put moles on bottom. So I need to find a ratio of moles to molecules, and that is right here on the top. 1 mole is equal to Avogadro's number, which is 6 point, not enough room. 6.02 times 10 to the 23. Okay, and there we go. The moles canceled out, and you're left with molecules. You do the math here. 2.4 divided by 84.01 times 6.02 times 10 to the 93 will give you your answer. Technically, once you do this enough, you could combine this together. You could just have 84.01 on the bottom, 6.02 times 10 to the 23 on top. Now, I've done this many years. I prefer doing the long way because I will have a less tendency of making a mistake. But if you could keep it straight in your head, you could combine those two together. So anyway, 2.4 divided by 84.01 times 6.02 EE. Oh, I didn't get the point. EE 23. And I get 1.71979. I'm going to write all of it. Times 10 to the 22. So we start off 2 sig figs. We're going to end right here. So 1.7 times 10 to the 22 molecules of NaHCO3. Okay, let me just double check. Times, whoops, divided by 84.01 times 6.02. Okay, got the same answer twice. Perfect. All right, so here it is. Unit going from moles to grams, grams to moles, moles to molecules, and then grams to molecules. Now again, if you wanted to go backwards, let's say you want to go molecules into grams, you do the same thing, but you're just going to flip all the ratios. So you're going to start off with molecules, and then you're going to flip this one. You start off, then you're going to have moles, so you're going to cancel out moles and have grams. So it's just the exact opposite. You just flick the ratios around. Hopefully that made sense. And then I'll now make a video on molarity.